Alright, in this video for lesson 7.3, I'm going to show you an alternate way to dividing polynomials. The book has us divide polynomials by using long division, and long division can be a long, drawn out, and actually a difficult process. It's really easy to make a mistake with using long division, so it is my least preferred method. And it's only necessary to use long division if what we're dividing by, which is what we call that, the divisor. Okay, so if the divisor there, if what we're dividing by, if that's a quadratic, meaning if I have something like x squared plus 2x minus 5 that we're dividing by, that is the only time that using long division would be necessary. In fact, even then, there's another version that we could use, or another method that we could use, but I'm not going to show you that one. But it's because it's not going to be very common that we're going to use where we're going to be dividing by a quadratic. So I want you to be familiar with this method. This method is called synthetic division. And when we do synthetic division, what we're going to do is we're always going to start by taking the divisor. Again, the divisor is what we're dividing by. Okay, so we have two terms: the dividend and the divisor. So you want to make sure you're familiar with those terms. I'll be using those occasionally here. Oh, and dividend, not dividend. Hold on, typo there. Okay, so dividend and divisor, those are the two terms you want to be familiar with. And so the first step is we're going to take that divisor and we're going to find the 0. So if I set that equal to 0 and solve it, I get x equals 1. Oops, x equals 1. Okay, so our 0 is x equals 1. What we're going to do is we're going to set that 1 outside of this box. Now this box is different from what we would normally set up as when we're dividing. This is just going to help keep things organized. Is the only purpose of this little line here, this little box. All right, so now what we're going to do is we're going to take and look at the dividend. We want to make sure first, before we start writing down numbers, that every term is represented. What I mean by that is if we have this in standard form, okay, so that's also important, it needs to be in standard form. We want to make sure that starting with the largest exponent, that every exponent after that largest exponent is represented. So what I mean by that is the degree here is 2, so our largest exponent is 2, and then we go down to a degree of 1, and then no variable, so no degree in that last term. So 2, 1, none is kind of what I like to look at. All right, so we have every term is represented. You'll see later in this video a situation where every term is not represented and what we need to do for that. But for this one then, what we're going to do is we're going to write down each of the leading or each of the coefficients. So my first coefficient is 1, my next coefficient is 5, and then we have 6. Now underneath that last coefficient, I'm going to put another little box here. This little box is going to be for the remainder. Remember, sometimes when we divide, we're left with a remainder. And if there is a remainder, it's going to be in that box. All right, let's get on with the process. Here's the process. We always start by just bringing down that first term. So there's nothing to add to that first term, so we just bring down a 1. Then what we're going to do is we're going to multiply 1 times 1. And we put that product, when we multiply the two numbers together, underneath the 5. And then we're going to add those two numbers together. So 5 plus 1 is 6. So we're going to repeat that same process now until we run out of numbers. So what I mean by that is here we have 1 times 6. So 1 times 6 is 6. So now I just add those together and I get 12. So that tells me that I'm going to have a remainder of 12. Now what does that mean for the 1 and the 6? What we're going to do, and this is why that box is important, is we're going to put variables in there. So in the first one, we're going to leave that as a constant. I'm going to leave that as a number. So whatever number is closest to the box stays as a number. So then we're going to go to the left of that and just put an x. And that's your answer. So our answer would be 1x, or just x, plus 6 with the remainder of 12. And the way that we write that when we have a remainder, the proper way to do this would be to say that's x plus 6 plus, and then we're going to write it as a fraction, a remainder of 12 over our divisor. Our divisor was x minus 1. Okay, so we have to go back to what we did originally. So that would be the proper way to write that solution. And the solution, when we're dealing with dividing, is called the quotient. So the quotient here would be x plus 6 plus the quantity 12 over x minus 1. All right, let's try another one together. This one we have x squared plus 5x plus 6. So it's the same dividend that we had before. This time we're dividing by x plus 3. So I'm going to start by finding the 0 for that x plus 3. Now you might be able to look at that right away and see that the 0 there would be negative 3. The one thing I want to make sure of is that you don't make the mistake of just looking at this and saying, oh, the 0 is 3. That would be wrong, because 3 plus 3 is 6. That doesn't give us 0 as our answer. So our 0 for this, well, like I said, would be negative 3. So remember that process. We're going to start by putting that negative 3 here. And then we're going to put the coefficients of our dividend, which is 1, 5, and 6. And again, every term is represented, so I don't have to worry about what happens there if we are missing 1. I'll show you what happens with that in a little bit. So we're going to put, again, our remainder goes down in this box. Okay, so we're going to repeat that same process that we did in the previous one. I'm bring down the 1. This time we're multiplying by negative 3. So negative 3 times 1 is negative 3. Now when I add those together, 5 plus negative 3 is 2. So that's the first step in the process. Now we're going to do this one more time. So 3 times negative 3 times 2 is negative 6. Now when I add together 6 plus negative 6, I get a remainder of 0. So there is no remainder for this one. So we can write our answer as just r plus 2. And there's no remainder. So when we divide x squared plus 5x plus 6 by x plus 3, we get an answer of just, oops, I don't know why I put r. It'd be x plus 6. Or, sorry, x plus 2. All right, let's look at this one. Now, if you notice that these first two problems, we had x plus 3, x minus 1. The leading coefficient of our divisor was 1. Look at this one. This one, our leading coefficient of our divisor is 3. Now, that is a problem, okay? That is a problem. Now, you might think, well, couldn't we just set this equal to 0 and solve it and use that? Yes, we could, but it would not work. Okay, so I should say, no, it doesn't work. We're going to divide everything. We want to get rid of that 3. So we're going to divide everything by 3, but that means I have to divide everything by 3. And we're going to leave these as fractions. So that means that instead of having 6x squared plus x minus 2, 6 divided by 3 is 2, so we're going to have 2x squared plus, I'm going to say 1/3 x minus 2/3. So looking at having fractions might seem freaky, might seem intimidating, but believe me, this is still much easier than using long division. And then when we divide it by 3 over here, we would have 3 divided by 3 is 1, so you just have 1x, which is what we want, plus 2/3. Okay, so now even though it looks different, we're still going to go through that same process. So our first step is, again, to look at what we're dividing by here and finding the 0 for that. So hopefully by now you're recognizing that the 0 of that would just be negative 2/3. So we're going to put that negative 2/3 outside that box. Now I'm going to go and look at my divisor. Again, we're looking at this new one. And yes, every term is represented because we have a 2, 1, and none. Okay, so writing down those leading coefficients, or those coefficients, we'd have 2, whoops, I want a pen, not a highlighter. We'd have 2, 1/3, and negative 2/3. We're going to have our box for a remainder if we have one. Okay, so let's go through that process. So we're going to bring down the 2. Now when I take and multiply negative 2/3 times 2, leave that as a fraction. Negative 2/3 times 2 would be negative 4/3. Now the nice thing is we have a common denominator here. So when I add those together, 1/3 plus negative 4/3 is negative 3/3. Well, what's negative 3/3? Negative 3/3 is negative 1. So now we're going to take negative 2/3 times negative 1. Well, that would be a positive 2/3. When I add those together, I get 0. So even though it looked like it was going to be a challenge because we had fractions, it really wasn't a big deal. All right, so now remember the process as far as writing our answers. So what's immediately next to that box stays a number, so it's going to stay a negative 1. So all I have to do is put an x in there. So my answer would be 2x minus 1. Oops, don't know why that happens sometimes. All right, let's look at one more example. Now this one, if I look at my divisor, I'm good there. Now it says an r, no big deal. Treat it the same way, but what I'm getting at is my leading coefficient. My coefficient for the r is just a 1. Let's look at our divisor though. I'm sorry, our dividend though. We have our exponents. My degree is 4. So we have 4, 3, 1, none. we're missing a square. So that means we have to put in here a 0r squared. That's really important. If we're ever missing a term, we need to make sure that every term is represented. So if we're missing a term, we need to put a 0 in there to hold that position. All right, so let's set this set up. So our 0 here would be -2. So our coefficients would be 3, -8, 0 for the 0r squared, and then 1 for just a plain old r, and then we have 20. Put a box for our remainder. Now this is actually one that is in your notes that you're going to work on here in a little bit if you watch that when you watch that next video. So in that one you're going to see how to do this using long division. And again, you do not have to do this with long division, and this will help you appreciate just how much easier synthetic division really is. All right, so we bring down the 3. -2 times 3 is -6. -8 plus -6 is -14. So what we're doing is I just multiplied this, and then we get the -6. The -6 plus -8 is -14. So now I have to take -2 times -14. Well, that's a positive 28. When I add those together, I get 28. Now I'm going to take -2 times -26. Well, that's -56. When I add 1 plus -56, I get -55. So now I'm going to take -2 times -55. Well, that's a positive 110. And when I add those together, I get 130. And that's okay. Just means we have a remainder of 130. So now we got to put in our values. So we're dealing with r's here. So remember, what's closest to the box stays a number. So it's going to stay a constant at -55. This would be an r. Now we have not done any like this where we have other ones beyond the r or beyond the x. So we're just going to go in ascending order from right to left. So meaning we have r here. So this will be r squared. And that means this will be r cubed. So your answer would be 3r cubed minus 14r squared plus 28r minus 55 plus, remember when we have a remainder, we say it's plus that remainder over the divisor, which was r plus 2. So that would be your answer for that last one. All right, so now you have an understanding of how to do these with synthetic division. I do want you to watch parts of the video for the next section just so you can see how long division works. But again, the only one that you're going to be required to know how to do on your quiz and on your test this year is just synthetic division. And even in pre-calculus, they teach long division, but they'll also let you use synthetic division. So they'll teach you both methods there as well.